So welcome everyone again to the talk, from Toil to the empowerment, building self-service Ingress with GitOps. My name is Jeswin, Koshy, Ninan. I'm working as a senior software engineer in Workday, specifically for the service mesh of Workday service mesh team. So yeah, let's start with the agenda. Here in this talk, I like to share about a transformation journey of the Ingress stack management, which we have done and which was very successful for our Ingress management. I will also share some details of our implementations that will be definitely going to help you. So let me start with a question. You might wonder, what is Ingress? Probably everyone knows about Ingress, but definitely there will be a question why we are talking about Ingress stack management in SREconf. Think about a scenario where your application pod is crashing, and it will be definitely a disaster. You will be declaring that as a disaster. And think about the Ingress itself is crashing because of some weird reasons. So what will be that? It will be an absolute disaster. I hope you guys are agreeing with that. So it is really matter to manage how we manage Ingress, since it is one of the major critical piece of infrastructure that can potentially cause big problems. So let's talk about that in a little bit more detail. To give a context, this is how the Workday is accepting your request, basically, or this is the network path of our Ingress layer. So client make the request. With the help of DNS, it finds the recipe IP and will finally land on our firewall edge or our edge infrastructure. And from there, a secured connection will be forwarded to different layers of our firewall. And only legitimate and filtered requests will be going to our respective load balancer, which is a pass-through load balancer. From there, it forwards directly to Istio gateway. And finally, based on the routes configurations, it will be going to the respective pod endpoints. This is how Workday processes your request. And all the end-to-end communication is fully encrypted or fully secured. And from the edge to our respective pod endpoints, it is mutually TLS. So let's start the journey of the transformation which we had. So we got started. This was our initial model, and we got started with this. This is like a fragmented approach, where you can see that all which are in green, such as load balancer, Istio service mesh, Istio Ingress gateway, we're managing completely within the scope of Kubernetes or in Kubernetes native model. But in the red box, you can see that such critical services such as DNS zones, DNS record management, firewall and edge configurations, certificate configurations, all which are in red, we're not managing inside of Kubernetes, or which is actually managed through a different set of tool sets, and it is not in Kubernetes native model. And what was the outcome which we had with respect to this kind of model? And I'm pretty sure that majority of us sitting here may be still managing this model of infrastructure, because we have the comfort of dealing things within the scope of Kubernetes. We will be going to use that, but especially with DNS and the firewall edge configurations might be sitting outside of Kubernetes. The outcome has two phases. I like to start with the phase of the internal platform users, where they deploy their applications into our platform. For them, I would say it's a terrible developer experience. They will submit their virtual service, which is the way how they make the configurations, the route configuration or the host configuration, which they want to expose. And they will get a terrible developer experience. Along with that, it will be an extremely slow process that they have to wait for the infrastructure team to set up their DNS records or the certificates, the TLS certificates which they required for, or even the edge propagation and edge configurations, which it is requires for them. It is not really a matter in the perspective of SRE, but as an SRE or as a platform engineer, it's a massive problem. That means we have a fragmented toolchain. We have to fight with different set of toolchains. For example, for managing the DNS records, I need to go and use a different configuration language. And it is also a model of inconsistent configurations where it can cause more errors and problems to our platform, and extremely hard disaster recovery when you go with that model. And moreover, it doesn't possess a lot of observability. We Workday focus on developer-first platforms. That means we like to have everything in code, not just using the configuration languages or anything which is outside of the platform to manage our things. Instead, we like to keep everything in the code because the point of lack of testable infrastructure. We like to make any sort of changes even to the infrastructure with the help of all of the unit test cases or whatever the development practices which we usually follow for any application there. And what was the solution which we did? It's a normal recommended approach which is followed by many organizations, and we followed the same model. What we have done is we put all the management of different components, which is in the red box, converted into the Kubernetes resource model. And at the end of the day, it is a operator-driven logic. At the end of the day, what is Kubernetes resource model? It is the readable format to define your desired system state, and the state of the system is achieved with the help of the code at the end of the day. But the thing is, to achieve that kind of maturity, we have to start searching for the solutions. I mean, start searching for the different types of operators. That is the model of Kubernetes. We used a mixed approach where wherever it is applicable to take an open source project. For example, external DNS can be used for the DNS record management. Cert-manager can be used to manage the TLS certificates and all. But there are certain cases where we can't directly, or we don't have a way to use the open source projects, because literally that will not solve our use case. And also, I like to just tell that all our capabilities, Ingress capabilities, are deployed completely through the GitOps model. So it is fully declarative. It is managed completely through the code, and we wanted to write certain operators for it. In the next slide, I like to share one of our case study which we have done for solving the DNS on management with an operator which we developed. It's called a zone provisioning controller or an operator. So in the left side, you can see that I'm just writing a for-line code or a YAML declaration. What I'm saying is, hey, this is my cluster called test cluster. This is what my name of the resource called test cluster zone. And this is what I'm going to achieve. This is what I wanted to get allocated as a DNS zone to the particular cluster. So I'm also declaring that, hey, I need a zone name called test.cluster.workday example-domain. And at the end of the day, what will happen? The zone provision controller will going to watch my resource or the custom resource which I have done. And in the right side, you can see that is the state which is currently in the system. That it reconciled. It have done a lot of operations at the background, but you will get a zone allocated and tied to a respective cluster. So at the right side, as you can see, the right side, I can see that the zone is got allocated. You can see that from the message, and it also shows what is the name server it uses. and it also shows the status as ready, and also, again, it will tell the, basically, it's all about the metadata, which it is given back to the user. Along with that, you can see a lot of metrics has been shipped. So this way, you can able to understand that if anything goes wrong with your infrastructure, even with a DNS zone or even with a DNS record management or whatever it is, you can able to completely monitor, and you can able to completely able to understand from your observability system. So behind the scenes, it done a lot of things. When I'm requesting to create a zone and allocating to a cluster, it talks to the backend DNS layer, and it created a zone. It makes certain AP operations to create the zone, and it creates the ownership records, because it needs to be allocated, and it should not be reallocated to a different cluster. So this was the outcome. So this is the outcome which we had after we made all of those changes. It might not be very readable for you, but at the end of the day, what we have done is each and every Ingress components which we had, it's completely managed to the GitOps model. Wherever we have an opportunity to take the open source project, we have used that. And wherever we have to write an operator, we write it from this chart. Especially the WAF management. That means when a user is going to submit a virtual service, it needs to send the routes. It needs to propagate the configurations even to our edge servers. For that, we use a completely built operator, which is called as firewall operator, which we call as. And it will do all sort of work which is required for us to manage the edge configuration, origin configuration, or whatever which is respect to that. And similarly, for the certificate management, we use as cert-manager, which is a well-known open source project. I'm not going to talk well about it. You might already know about it. And for the load balancer, we use as the respective provider operator, major cloud provider operators to manage our load balancers. And for the DNS zones, as I mentioned in the previous slide, that is how we manage the DNS zones, which is allocated. So what is the outcome here? So it also has us two phases. For the internal platform users, for them, it was like a nightmare for them to to propagate their or to expose their services to the outside world, because they need to do a lot of interactions with multiple stakeholders in order to set up that, for example, DNS record or the edge configurations and all. And for them, it is like very easy developer experience that within the next reconcile of these operators, it will do all the things for them like in a couple of minutes. So it was a very good developer experience for them. Definitely, they definitely want to go through several approval process, for example, for security and all. But once it is actually submitted or requested in the cluster, definitely it will be going to be propagated very soon. And for us, as a platform engineer, we also got a nice outcomes, such as all our management of these operators is completely completely went through every integration test. I mean, we are getting a lot of opportunity to test our infrastructure changes before going to the production. And also, it is emitting a lot of metrics, and which gives us a very good observability opportunity for us. And also, it definitely helps us to manage very easily. For example, thing like a new cluster is getting provisioned, and the provisioning team don't want to talk to us. They just want to get an approvals with respect to these resources. And once it is got approved, all the things will be handled at at the background with the help of these operators. So at the end of the day, it will be a win-win situation for our users, as well as it reduced a lot of toil, and it is completely a declarative model with a lot of good outcomes as a platform engineer and an SRE. With this, thank you, and